Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to see about a Leetcode question number 173, binary search tree iterator. Implement a BST iterator class that represents an iterator over in order traversal of a binary search tree. So inside that, we are going to initialize a constructor inside which they will give the root as a parameter. And we want to define a member function of as next that represent whether we have a next node in our iterator or not. And we have an int next which just returns the node of the current iterator. Okay. So, and they are also given, you may assume that next of calls will always be valid. Okay. So it won't be called by the null, or it doesn't call for the after executing all the BST nodes. Okay. Now, let us understand by using this example. First of all, I'm just initializing an object, okay, and giving a tree. Okay, what is a tree? This is a tree, and I will pass the root. Okay, now, next, if they are asking the next, what is the output? It is 3. It is 3. Why it is 3? Because if I do an in-order traversal here, first of all, I will say you what will be in-order traversals here. First, we will take the left, then we take the root, then we take the right. So, this is the steps for the in-order traversal, okay? So, this is the order. If you want the in-order traversal, I will give the link in the description. Just go and watch it. So there will be a full text. Okay, and try this question also. After watching that, just try this question. If you can solve, just solve it. If you don't worry, just come back. I will just resume this video. Okay. Now, see here. First of all, I will print this string or return this string, right? Why? Because the next one at first will be 3 only. Then after that, next means what? The next element will be what? 7. Then as next, whether it has next, yes, we have still 3 more node. Okay, then next means what? That's 9. So we know that in sorted order, only the result will be right in the in order traversal. Simple. And again, as next, whether we have next, yes. Now, next means what? That's 15. Okay, now as next, we have next. Okay, now next, which means 20. Now as next, it will be false because I just traversed entire node in the binary search tree. Yes, so I'll write a plus. Hope you understand this, right? Okay, now how we are going to do this? Okay, let us understand by taking this example. So first of all, just to know how to do that in order traversal, right? Okay, so simpler way to solve this question is that take an array, and put each and every element in the array. Okay, and return one by one. Okay, first of all, I am here, right? Now, what's my in-order traversal order? It is left root, then only right. Okay, go to the left. Now it is null. Go back. It is a root. Place here. And go to the right. Null. Go back. Now it is what? The root. Okay, place 7. Now go to the left. Go to the right. Go to the left. Now again go to the left. It is null. Go back. It is a root. Put 9. And go to the right. Null. Go back. Now it is a root. So put 15. Okay, now go to the right, go to the left, null, go back, and it is what? Root, so 20, and go to the right, null, go back. Go back means what? Just backtrack in our represent. Okay? So, this is our order of the in-order cell. Now, what is the next step? Next step is so simple. Just place a pointer here. Whenever I am asking you to print the next value, just return that arrays pointer, and make that pointer to move one step ahead. Because in next step, it will be something like at this 7, right? So to do this, instead of returning here, just take this as value and return here. Return the value. Simple. So these 3 lines of code will be what? The next function. Simple, right? Now, as next. Okay, if I asking you, you are at here, okay? You are at here. If I ask you whether you have any next element, what will you do? I will check whether here there exists a 7, right? So, how we can check it? So, we have in this, right? For 0, 1, 2, 3, 4. So, if I have a pointer in this range, I can say as next will be true. If it is beyond this range, I will tell you as next will be false. So, return if the pointer is less than the top, the len of this array, then I use to return what? A true. Can you understand this? So this is the whole set of code for this first method, right? So this is the first method. So this is the array method. This we are taking into an array. Okay. Okay, fine. What is the time complexity and space complexity? I can say time complexity will be 1 and space complexity will be 1 for these operations. But when we are using a constructor for this operation, this will be time complexity, and for constructor specifically, the time complexity will be what? O n, because I am traversing the entire node. That's the first point. And what is the space complexity? Space complexity will be O. I'm taking an array, right? So it will be O. Yeah. So this is the constructor time and space. Can you understand this? So this is a design problem. Hope you understand. Now, whether we have any other method, it should not be efficient, but we want to see all methods, right? So we have another method. The another method is something like a stack method. First, I will redraw this. So 7, 3, 15, 9, 20. Okay. Now, let us understand the stack method. Initially, I will take a stack. Okay. And hope you know the in-order traversal by using the stack. If you don't know, just go and watch my video in the description. Okay. Now, initially, what we are going to do is we will take all necessary nodes into our stack in our constructor itself. So in our constructor, what is my procedure is that first I am standing here, right? I am standing here. So take this 7. Okay, go to the left. So 3. Go to the left. It is null, right? So stop here. Stop here. This is the method for the constructor. Okay. Now, if I ask you the next op, see here. Now to this, we are going to do in a constructor itself. Okay. When I am asking you the next op, what should we do? First of all, we should take the topmost element. We should take the topmost element and pop it out. You may ask why we are popping it out. Because that should be the in-order traversal element, the current element. So pop this out and return this. Before that, we are just leaving one thing. What's the thing? If this element has any right, then we want to put inside, right? So that will be taken care in this constructor itself. Okay, I will tell you. And again, here also we are going to check whether it has any right. No. So don't do anything. Just return this 3. Okay. Now, again, if I ask you, ask next, then what should we do? I should check this stack. Whether the stack is empty. No. So don't do anything. Don't do anything. Just return. Okay. Now, again, if I ask you, and next up, again. So I will pop this 7 out. Okay. The 7 is written. Okay. 7 is written. But before that, what should I do? I already said here. What should we do? We should go to the right side and go to the left side and again go to the left side. So while going to the right side, I will put 15. When going to the left side, I will put a 9. And again going to the left side, it will be null. So I don't want to put it. Understand this? So this should be done. Next will be returning this 7. Can you understand this? Now again, if I ask you the next, then I will pop this 9 out and I will go to the right side, but right is unfortunately null. So don't do anything. Now again, if I ask you to do the next off, then I will pop this 15 out and return this 15 as our answer. And before that, I want to go to the right side and push this 20 here and go to the left side. It is unfortunately null. Stop here. And if I call you ask next again, I want to check whether this stack is empty. No, this is not empty. So I return what? A true. True. Now, if I ask you to do that next, then what will you do? You will pop this 20 out. Now, what is the 20 side? It is null. So we don't want to put anything. Now, if I ask you to do ask next, what will you do? We will return a false. Why? You may ask why we are returning a false. Because the stack is what? The stack is empty. Which means what? The length of the stack is 0. So I will return what? A false. Hope you understand this approach, right? Okay. Now, what is the time complexity and space complexity for this constructor? I can say the constructor time complexity will be something like how many times we are running this constructor. It will be only the height of this. So I can say it will be work or almost to the log n. If it is a balanced binary search tree. And what is the space complexity? I can say space complexity will be I'm taking this entire tree in our class member, right? And also I'm taking the stack, so it will be O of n more t. So this is a time and space function for a constructor array. You may think it is a efficient solution. Yes, it is a efficient solution, but wanting a little. Okay. Let us next move on to the next of and as next of time and space complexity. Okay. Just tell me what is a time and space complexity. I can tell you that this both will have a time and space complexity like this will have a time and space complexity as O of 1 only. Okay, for this as next it will be O of 1 only. But for this next, it may in our worst case will take this entire time, right? So it will be O of X. At our worst time comes. Yeah, space will be what? Space will be the stack space only. So it will be also taking the n. So it will be like H or the stack space alone. So it will be H only. Okay, can you understand this? So this is the time and space of the analysis. So from this, I can say, if take for example, if I have 1,000 binary or 10,000 binary node, but I only called for next up only. I am calling for next up only. Then tell me which is the advantage, whether a stack approach or array approach. Stack approach is advantage because stack approach will take a little by little according to our requirement. But in array, we will take the entire and dump into the array. Can you understand this? That will lead to the time complexity to increase slightly. But here, the time complexity will be slightly low. What growth will be same, but time taken will be quite low in this stack approach. Can you understand this? But if I ask you to take this all elements that next and as next, like that, if I go up to all elements, then this both will be same. This both will be equal. We got time and space complexity. Can you understand this? Okay, let us see the code. First, we can see the stack code. See here. First of all, I'm just initializing a DFS function. Okay, inside that, I'm just passing a root, a while root. I will go to the beyond the left, the most left, and take everything inside my stack. So this is the DFS function I wrote. Okay, why I'm writing this DFS function? Because we are going to use this DFS function in both next and also in init. That's why I just commonly used it. Okay, now self.stack is equal to empty stack. Now I'm calling this DFS function. Just I put this entire thing inside. Okay. Now again, DFS of next of self. Okay. Top is equal to self.stack.pop. So I am popping this, and then self.dfs of top.right. So I'm just taking that right value. Okay. Now return the top value. That's it. So this is the next code. Okay. Now as next, in the as next, I will return what? If it has any length. If length is equal to 0, it will return false. Okay. I wrongly said that here we will take the entire tree. But here we don't take the entire tree because we have the address, right? So the time complexity will be what? O of H only. Sorry, space complexity will be what? O of H. Sorry, I just mistakenly told you wrong. Okay, now let me submit it. So just wait. I just forgot what comment it. Yes, it is submitted fully. Now, let us go to the array approach. Okay, this is the array approach, right? In array approach, it is so simple. Just see here. First of all, I am taking in everything inside my array by using what? A DFS in-order traversal. Here I turn the in-order traversal. Then I keep the pointer as what? A 0. Now, when I am asking a next, the same code I written in drawing myself. I written the pointer's value, and also I will increment the pointer by 1. And in as next, I will return what? If the pointer is less than the length of the in-order array. That's it. So this is the entire code. Let me submit it. Yes, it is submitted. Thank you.
And we have the .com.
So the net to be to feel like